Welcome to Temple Emanu-El's celebration of Tu B'Shvat's Green Week. Tu B'Shvat is the birthday of the trees. Tu B'Shvat is the Jewish Earth Day that goes all the way back to pre-Second Temple time, so the Second Temple period. Tu B'Shvat is the way that we Jews embrace, celebrate, connect to, preserve, guard the earth. Now, clearly, at different points in our long history, Tu B'Shvat has had various meanings and various degrees of poignancy. When we Jews were living in the land, call it 586 BCE to about 70 AD, Tu B'Shvat had a particular flavor having to do with tithing, taxes, and fruits, meaning that a certain percentage of what we produced would go back to the society in which we lived. None of us were able to earn or produce in a vacuum, and the society itself and the world around us was to benefit from whatever we produced. Once we were off the land for, the 1500 years up until the Sot folks came with the Kabbalists in the 16th century, Tu B'Shvat went into a wintry, dormant phase. It was still part of our holiday culture, but in a very subdued way. And yet once the Kabbalists in northern Israel, in Sfat, came back into the land, all of a sudden Tu B'Shvat once again bloomed into something highly spiritual, with the metaphors of trees and certain fruits and nuts used to talk about the klipa, our outer shell, that needed to be shucked in order to get to the chidush, the inner part of ourselves, which was our spiritual essence, and that which most connected us to God, our community, and all that we could be. We Jews have a long tradition of seeing ourselves having a mission in the world, a reason for being. We believe that the world is sick and broken, and that we Jews have a divine mission going all the way back to the beginning in every Jewish generation, every Jewish family, every Jewish individual, to help tikkun olam, to help heal a world which is broken, that's sick. That is our mission and reason for being. So, with the onset of Tu B'Shvat, which happens on Monday, Temple Emanu-El, we are in the midst of our Green Week, a full week of raising awareness and consciousness so that we can actively engage in the Tikkun Olam of healing a world which is before us in trouble, environmentally and otherwise, but tonight we'll focus on environmentally. Last night we had a wonderful speaker. Tonight we have another. I'll have Robert Wittenstein in a moment come introduce him. Friday night, tomorrow night, our Shabbat service is going to focus on the environment. The Saturday Torah study is going to focus on the environment. And then on Monday, we are all going to meet at Brook Run Park for a Tu B'Shvat Martin Luther King Day tree planting fiesta. Bring your comfy clothes. It's going to be fun. So, this is very important to us as who we are as a people and who we can become as a people. And with that, I would invite up Co-President Robert Wittenstein to give words of introduction.
Thank you, Spike. So I want to start first by thanking our Green Team co-chairs, B. Grossman and Karen Singer, who are in the house, and who have helped coordinate a lot of the activity that we have successfully completed over the last 4 or 5 years. Of all the synagogues in Atlanta, we are one of the ones that is leading the effort to make our synagogues an example for the rest of the community, and I'm very proud of the work that we have done. Before I introduce Mark, I am often inundated with environmental emails, and one of them struck me today. There was a line that I was particularly struck by, and it was a Kenyan proverb. And the proverb is this: treat the earth well. It wasn't given to you by your parents. It was loaned to you by your children. Love that. Now let me introduce Mark Elliott, an award-winning storm specialist and on-camera meteorologist for the Weather Channel. He has been part of the Weather Channel broadcast team since 2004, and since then he has been part of the coverage of just about every type of weather phenomena. Mark holds a dual major undergraduate degree from Rutgers University in meteorology and environmental science physics, and he continues his studies at Georgia Tech, completing a Master of Science in Earth and Atmospheric Sciences. He is a long-standing member of the American Meteorological Society. I had to practice that word several times today. And the National Weather Association, and has held various board and committee positions, including currently serving on the AMS Financial Weather Climate Risk Committee, where he is the organizer of the Financial Weather Climate Justice Initiative. He also serves on the executive board of JCAN Georgia, the Jewish Climate Action Network of Georgia, which is where I met Mark, and is our chief climate officer. Mark is a frequent interviewee with NPR, including for their national show Here and Now. And while not talking about weather, Mark enjoys traveling, craft beer, running, and occasionally running to craft beer. So he will find a run that terminates at a craft beer place, and he will run to the beer, which sounds like a wonderful idea if you are a runner. At any rate, with great appreciation for him being here, I'd like to introduce Mark Elliott.
All right. Thank you. Wow, what a nice intro, and thanks so much to all of you for bringing me here and for doing this week. This week sounds amazing. I kind of wish I was kind of stealing entrance tickets to all of it. I know tickets, but whatever. It sounds great, and props to all of you for having this in your head to do in the first place, and then organizing it and doing it. It's really spectacular. So for everyone that's watching, and then for all of you guys that are here, thank you for all that you're doing and for being here. Let's start by, they say, you're supposed to tell the audience what you're going to talk about, then you're going to talk about it, and then you're going to tell them what you talked about. So let's do that. We're going to talk about the state of the climate and break that up into several parts, assuming that people know nothing about climate change and environmentalism, which I know isn't the case, but I like to make it an even playing field and get everyone up to speed. So kind of real basic stuff. It's simple. The science is simple. Unfortunately, the science is also really serious at times, that things are not always looking cheery in this talk. So it's simple, it's serious. As you heard from your rabbi, it's Shalom. It is so crucial that the Jewish community is involved in this, and we have to be, because we are, through history, through time. You got a little precursor to that whole section, so I get to breeze through it because he said it better than I ever will. And it's solvable. So after it's simple, it's serious, it's Shalom, and everyone's on the dirty linoleum floor and drinking cheap scotch and just really down, we get to bring everybody back up and say, we actually can do something about this. This is a solvable thing. It's not too late. We're going to be okay if we do something about it, which is potentially easier than you may think it is, right? It can feel very, very difficult. So that's what we're going to talk about. We're going to breeze through the parts that are easy. We're going to slow down at the parts that are hard. You can interrupt at any point and ask questions. Then we'll leave a bunch of time for questions at the end as well. When I click the next button, things start moving. And so before I do that, a piece that was created through the Weather Channel and through the National Science Foundation in a partnership to be used in classrooms to kind of explain what climate is and why it matters and why it's different from weather. And I figured that was an easy enough way to get things started today.
It's Weather 101 time. Today's topic is weather versus climate. Class is in session. We all know what weather is, right? That outdoor environment that you experience every single day. Climate, on the other hand, is the average of all of this changing weather taken over at least a 30-year period. Think of it this way. If you take your dog out for a walk, that random kind of meandering path of your dog represents the changing weather. But you take a more direct, less variable path. That represents the climate. So what about climate change? Over the past several decades, the burning of fossil fuels and buildup of greenhouse gases have been trapping more and more heat in the Earth's atmosphere. That caused the planet to warm rapidly. And if these gases keep increasing, so will Earth's average temperature. This rapid increase is unprecedented in Earth's history. In the coming decades, this warming and our changing climate will force us to have to adapt to rising sea levels and new, potentially destructive weather patterns. And some people are already feeling these impacts. How will this affect you? For your extra credit assignment, learn more by going to climate.gov.
And so that is like everything that you'll see in this talk. As soon as it's in here, it's already old. And so when I made that, I think it's probably 2 years ago now, if it were made today, I would have said, everyone is already feeling the impacts of these changes. It was a little bit less certain then. The science continues to evolve, and we'll talk about how that science has grown and has changed along with climate change. There's lots of change in this talk, but some of the graphs that you'll see end at 2019, and some of the new data is out now for 2020 and 2021 even. But again, as soon as we put it in one of these things that are frozen in time, it's already old because there's new data coming in all the time. So we'll go from there to it's simple. The science of climate change is actually really simple. We've known about it forever, right? They say in a synagogue, if you've done something for 5 years, it's been that way forever. Well, in the scientific realm, it's a little bit longer than that, but there's been studies since 1896 when a Swedish chemist, whose name I'm not going to try to pronounce for you because I will absolutely get it wrong, concluded that industrial age burning of fossil fuels will enhance the natural greenhouse effect and will have a real impact down the line. That was 1896. We've known about this for a long time. As another example, this happens to be from New Zealand, from the Gazette there, right? And this article was from, I believe, 1912. The furnaces of the world are now burning about 2 billion tons of coal a year. When this is burned, uniting with oxygen, it adds about 7 trillion tons of carbon dioxide to the atmosphere yearly. This tends to make the air a more effective blanket for the Earth and to raise its temperature. The effect may be considerable in a few centuries. And here we are, right? This is in a newspaper in 1912. This is not new science. It's not groundbreaking information that scientists are just coming up with. The only part of this debate that's new is the public debate over that part of the science. The science is actually really clear. In fact, scientists agree on this overwhelmingly. It's really hard to get all of us to agree on anything, but even with that, about 2 years ago, the amount of papers that were peer-reviewed and in journals about climate change, 97% of them not only said that climate change was happening, but that it was us, that it was people forcing this change, that it wasn't a natural cycle. Now we've broken through that number, and it's actually 99% of journal articles that are in peer-reviewed process agree. So again, really hard to get that last 1%. I don't know if we'll ever get to 100, but that's as overwhelmingly certain as science ever will get. Is basically there. And then we can look at this chart because we can just kind of use the smell test even without the true science. If you look at that black line, that's the bouncing of the temperature year to year, the global average temperature, all the high temperatures, all the low temperatures averaged together globally for a year. And then you look at the red line, which is the increase in carbon dioxide or the trend in carbon dioxide. It just kind of fits, right? That's not enough scientifically that it just kind of looks right, but for us, normal people, it's pretty clear that there's a relationship here, and that shouldn't be ignored. So scientists agree about that fact. The total carbon dioxide from industrialized humans in the past 263 years or so, give or take a year or two, is 1,480 billion tons, give or take a billion or two. Well, what's a billion among friends, right? If you wanted to add that current rate of CO2 naturally, you would need an Africa-sized wildfire every single year. We know that this is not something that's happening naturally because we'd find that. We'd see an Africa-sized wildfire if it were occurring every year to add that much CO2 into the air, and we're not. Here's another way of looking at this. This is known as the climate spiral, and what you're doing here is going through time, starting off in the 1800s. Here are the average temperature and how that temperature has changed. The 1900s, we start the industrialized revolution, and suddenly the colors are getting a little bit farther away from the center line. We're doing more and more of this through the world wars, the 40s, the 50s, here go the 70s. Everybody's turning on, even some new countries around the world, and then we suddenly explode outside of where we were in that beginning of the chart. That is the same information as you saw before on that, straight line or curved line up, but now this spiral is really telling. And we're worried about getting to 1.5 degrees C and the Paris climate agreements about getting to 2 C. That's why those rings are on there. You can see we were rapidly accelerating already towards those numbers where we know that much more damaging impacts and effects will occur globally. And we'll talk about what those are coming up as well. So it's a real thing. And a little bit of the science of how we know it's real and we know what's happening. The climate has always changed. That's one of the big, if there's a skeptic, well, the climate's always been changing. We're just this little piece of it. Well before humans and well before the industrialized revolution, the climate's always changed. And that is absolutely true. But it's also true that it's never changed at the rate or the degree that we're seeing now. And all the indicators that we would talk about, it would be predicted, have been occurring as well. So first, never at the rate that we've seen, that's what this chart is. So basically all of agricultural history is this little part right in here, where we have this nice little balance and farming begins and societies pick up and increase in this reasonably flat line in the middle of our chart. Human civilization basically started here, but the bulk of our history is in that nice little warmish zone. Now, we're at this black line that's almost straight up and almost impossible to see. That's where we're at now, and we're worried that we're either on this red line going this way, or can we kind of turn that and stop the most destructive parts of the climate changing and the temperatures increasing by curling that around. A lot of the science says that this yellow bar is kind of baked in already from what we've done already. There's some new science that says that that's not necessarily true, that the Earth is far more resilient than we gave it credit for in some of those earlier studies. And if we were to get to net zero emissions, no more carbon dioxide going into the air, that the Earth would recover quite quickly compared to this purple line going all the way up past 2C. We'll see. That is an area that does still have some debate within the scientific literature at this point. But again, all those indicators that would be predicted to occur if climate was changing and if it was us have been happening. So I know there's a lot going on this map, so I'm going to break it down for you really quickly. Around the outside is all of the data that is tied to these letters. So A is a temperature, and this is a temperature map, etc. Predicted before, years before, if there was climate change, temperature would be going up, heat waves would be going up, heaviest precipitation days would be going up, the snowpack across the western United States would be going down, E is somewhere in there, drought conditions would be very changeable depending on where you are, droughts that end as flood, but then droughts that last longer, so a little bit in both directions. F, the sea ice extent would go down, the sea level would go up, the marine species distributions would start to change, the acidity of the ocean would start to go up because of carbon dioxide dissolving into the oceans, which then adds an acid. Growing seasons would get bigger. We'd have the potential for more food, feed more people. Wildfires, however, would also go up because of longer drought and more fuels for them because there are more things growing at different times of year. So these things are tied together. The spoiler alert is that all the data shows that all the things that were predicted have already started to occur. So all of the indicators that you would look for if climate were to be changing and if it were to be changing because of us have started. Again, another way to know that it's real, it's us. It's not just a normal cycle that could be occurring. So the scientists agree it is a real thing, and again, it's simple science that is absolutely us. Because we know that atmospheric carbon has never been at a level that it is now, which is what you see here. This is where, using ice cores and using tree rings and using all kinds of other paleoclimate studies, this has been created in the past. You warm up and you come out of an ice age, a new ice age begins and you crash back down. These things are related, both the carbon in the air and the temperatures, and yet here's where we were at 1950 and here's where we're at now, except this graph is old and so it's kind of already up here. It is a crazy straight line up that we've never seen even remotely close to before we started helping these cycles. And again, we model this just to be extra sure. And if you look at this, all of the natural stuff, the volcanoes, the changes in solar radiation, the tilt of the Earth, the wiggle of the Earth, the wobble of the Earth, which are actually different things on the axis, but all are ways that the climate can change, right? If you somehow tilt away from the sun a little bit more, you're going to get colder. And if you tilt towards summertime happens, you tilt towards the sun, you're going to warm up. If the globe did that on a bigger scale as it went around the axis, you could understand how natural variations can change the climate. And so they modeled this going back to the past and used our climate models that we use now to predict the future and say, okay, well, let's start it from 1900. Let's find out what happens if we start it from the past. And we did just the natural stuff. And then we said, okay, well, that didn't match the observations, which is the black line. So instead, we added in not only the natural stuff, but all the other man-made stuff that we could think of. The changes in CO2, the changes in all other greenhouse gases that we'll talk about coming up, changes in ozone, changes in sulfur, volcanoes, all kinds of other stuff. And because that was, volcano and solar and the natural, and then all the other stuff that we add in, and that's this red forecast or red prediction from running it back from the past. And suddenly we split and we keep up with the natural change that has the change that has been observed, I will say. The black line is the observed things that occurred. So using our climate models, we can tell that it's us because we went back in time and we ran it to today. And without adding us into the mix, the climate models fail. And I mentioned there's lots of different greenhouse gases. We're going to focus on carbon dioxide from fossil fuels a lot because that's this part of the chart. It's a big deal. It's not the only big deal. You may have just heard from the Glasgow summit that they really want to limit methane. Methane's super important. Here's methane from agriculture, which is here. So that's a huge part of this pie chart as well. Can't ignore it. So that was a really important thing that came out of that conference. And yet, it's a little bit distracting when this is CO2, this is CO2, this is CO2. So you got 3/4 of the chart from carbon dioxide. It's really important. Methane is more powerful and lasts a really long time, so it's also very important. And there are other Oh, I zoomed in, look at that. There are other greenhouse gases that are also equally important to tackle, but again, the us part of it that we have the most control over is putting CO2 into the air. It's simple, the scientists agree that it's simple, and they agree that it's us doing it. What happens from that is often kind of bad news. It is a serious thing when we change the climate. It can have potentially huge and devastating consequences across every part of our daily lives. And a lot of the focus up to this point, this is starting to change now, but up to this point has been on this inner circle that, okay, the climate's changing, so there's going to be more rising temperatures and more extreme weather and rising sea levels and increasing CO2 levels, and it all kind of feeds in on that inner loop. That's what the Earth is going to be doing, less about what we on the Earth will be dealing with. So, some of the more direct things that start to happen after this inner circle conversation is that, okay, it's not just rising temperatures, it's extreme heat, or it's more severe weather, or more air pollution, or different bugs at different times in different places, and more allergens because of that longer growing cycle, water quality impacts, or water and food supply impacts. We've seen through COVID how damaging supply issues can be to the normal run of established society. And that's not even enough, because that's still 1 degree removed from what it really means for what climate will do to people, because that's the bottom line here. What will it do to us, to people on Earth? And it's not just extreme heat, right? That's what happens to your thermometer. What happens to people is that there's more heat-related illness, there's more heat-related death, there's cardiovascular failure, and more instances of cardiovascular disease and cardiovascular failure because of it. There's more injuries, there's more fatalities, there's a huge mental health impact to climate change, both the feeling of helplessness and the other impacts, creating extra stress that the human psyche wasn't really evolved to deal with, because we spent so long as a society in one temperature range, and we're breaking our way out of that. Air pollution means more asthma, again, more heart disease. Changes in the bugs means more malaria, more dengue, more hantavirus, more Lyme's disease, new and re-emerging diseases that we haven't been exposed to as a society. And, again, not that after, say, Superstorm Sandy, every single story was, is this the next Sandy? No, right? Is the next new or re-emerging disease the next COVID? Probably not, but do we want to increase more opportunity for new disease across the world that we have no recent exposure to? Also probably not. So again, these are real people-driven impacts that will occur as we continue to change the climate. I want to show you a couple of the images of this change, because it really speaks to what has occurred already, and we're going to kind of slide through some of these really quickly. This is a picture of glacier melt in Alaska. This first image from 1986, color-coded differently, so bright blue is the ice, and then this second image is from 2014, and notice the difference in just the 20 years or so, 86 to 2014, 30 years. A really big difference for the amount of ice that's there. Sliding down, this is deforestation in Argentina. So people having a real impact, but also, a huge climate influence by changing this amount of land. This dark green is all forest, and then this is not. It's burned. It's some cities, but it's often burned down to do palm plantations for palm oil, and those trees are then immediately cut again, and it changes the soil composition, and it often makes it almost desertification, whatever. There's more desert after doing that process. Things don't grow back as easily, and the long-term forest is totally changed. This is the urban expansion. This area is coastal China, where it was mostly green and mostly forest. This is Shanghai. now. So we have had huge impacts on what the Earth looks like, what the face of this planet looks like. And these are the changes that are happening. This is a really important one too, because of changes, both because of how Russia controlled the rivers and because of more use and more need. This is the Aral Sea in Central Asia, what was the Aral Sea in 2000, and then what is the Aral Sea in 2014. And this stuff that was underneath that water, all kinds of, again, new respiratory illnesses, it blows off in the wind. It's things that kind of were supposed to stay covered by water. But we use that water, and it's now a very important environmental impact in that area. So the change isn't always all bad. The population has exploded. The urban population has exploded, and you may say that's really good for innovation, for bringing people together, for centralized, not, the government being able to help people in one area. If everyone's in one area, there's some benefits to that. You see that in your workplaces. The GDP of the world has also exploded in that time. So we're doing way more productivity with those more people and with that urban landscape. The land use has changed dramatically. The forest loss, that's a forest loss graphic. We've dammed up the water. Those are large dams in the thousands, and then the water use has also increased. So again, both positive and negative change, but it all ties back to this climate story that we're telling. How about changes more locally? If you're in the Atlanta area, which we all are, and maybe you're watching from who knows where, but we're going to focus on Atlanta because we can. Here are some of the recent trends for Atlanta. If you think that it seems like it's hotter more, you're right. This is the trend of the days above 90 degrees since 1970. Just since 1970 in the Atlanta area, there's 27 more days per year on average that are 90 degrees or higher. That's a lot. That's a lot considering how much of a killer we know that heat is. The streaks of those 90 degrees has also been increasing. In 1970, the highest number of consecutive days was on average close to 10. Now it's approaching 15. So days in a row. If you can't cool down your apartment, if your AC breaks, if you can't cool down at night, you can't cool down at all because you have this long, long streak of heat, it becomes that much harder for the body to deal. Again, positive, potentially, the growing season is increasing. You've seen that in your backyard gardens. I have flowers that are still blooming right now on my driveway or have bloomed after winter began, which is really weird to see. These are not plants that are supposed to have sprouted, and yet they flowered this year. But it also means much longer allergy seasons. If you're like me and you suffer from allergies, having 30 more days of a growing season is really long when you're hoping for that frost to come in and give you a month or two break from the itchy eyes and all that comes with allergies. Flooding is a big story here across the southeast. The days with the heaviest downpours, the heaviest events, which is 3 inches or more, have increased just about everywhere across the U.S., but those days have increased more so in kind of the midline of the country, Mississippi River or so, and east. And in the southeast quadrant, 27% more of those days that have the heaviest rains. And that includes the Atlanta area. And I threw in a Charleston graphic. I didn't have Savannah, but Charleston, the coastal flood days, those natural days that you would have had some flooding because of a hurricane going by, or you would have had a high tide, something like that, have been reasonably steady, although also increasing because we're affecting those. But the non-storm nuisance day floods that are just because the sea level is higher, that is us, and that has exploded up. So now on sunny days at high tide on Market Street, they are closing shops, they are barricading roads because they are flooding without a storm. And some of their non-storm day floods and tidal gauges are just as high as some of the biggest names of hurricanes that you remember from 10 to 15 years ago in that same area. Add one of those that happens to also be at high tide, in one of the higher tide cycles, one of the king tide cycles, and suddenly you have huge amounts of water compared to where it was before. That can be devastating. Water is really damaging. And winter, as you've noticed, this only goes through 2020. It doesn't have this current winter and what December was like here in the Atlanta area. But winters have had a 5-degree average warming since 1970 here in the Atlanta area. I assume that this number will be even higher, even despite the cold that we've seen more recently through this month. December was so far off the charts, there's almost no way that this trend hasn't continued. So it's a real happening already story in the Atlanta area. And then Israel's a big part of this. This is a synagogue. This is a Jewish community. So let's talk about, if we care about Israel, we need to care about climate and what's happening there. This map of Israel that you see, it's a little bit small, so I'll point at it over here. All these brighter blue colors that you see outside Haifa, down through that kind of tip of Israel off the Mediterranean, the coastline in here, coming towards Elliot-State, I think is how you say it. I might be wrong. And then all the way down the coast, those blue areas are all regions that under even the more modest projections of climate change and sea level rise would be underwater by 2100. That is a lot of a very small country that could suddenly be underwater, including some of the most beautiful tourist lands and economic powerhouse places for Israel's economy. But it's not just about Israel. The caption on this is Palestinian fighting fire. Without getting into the politics of whether you believe a Palestinian is a Palestinian or an Israeli or whatever, there is conflict there, and adding fires and adding water scarcity and adding more stresses to an already stressful situation won't help. So you have to care about the people that are there. The average heat wave days per year in Israel, again, which is can be too hot and can run out of water. Water and water scarcity is such a huge part of our DNA and our culture of the story of Israel and coming in and changing the land. The number of days that are considered heat waves have exponentially increased in Israel. This is a very similar graphic to what I showed you here, but stretched out a little bit. So these are your daily high temperatures in Jerusalem, going all the way back to 1950. The red line is the trend, and it's in Celsius, so a little bit hard to understand for us, but still 21-ish in 1950 and 25 plus current day for your daily high temperature. That, again, is a huge change in Celsius. Multiply that by almost 3 for your change in Fahrenheit. So they've had a 12-degree change on the plus side for their daily high temperatures in Jerusalem. That is massive. And this is a look at Israel and each region and how their water may change. Again, the Negev, the red area, which has been growing because they haven't had as much water. And if you're taking out even more water, going from 300 millimeters per year to 255, going from 560 to 510, going from 780 to 775. There are a couple areas that do increase. This one, 580 to 650. You follow this line, it's all the way at the coast. They're already dealing with sea level rise. Now we're adding even more rain events to it. If the rain is happening while the seas are too high and there's an onshore flow and you can't get that water out, everybody floods. So more rain in Israel in certain areas doesn't equal good news either. So again, that's some of the change that Israel is experiencing. All of this, pretty serious. These are serious impacts that we're following. And I wanted to quickly show a thing that it's everyone. Some of this has some annoying sound. I'm going to see if I can probably mute this as it plays. So these are global impacts, but also impacts for the United States. I want to show you this one, which is Hurricane Dorian, with the annoying sound, which I will kill. Okay, so this is loops of satellite imagery, daytime and nighttime. So you see that line go through and suddenly it's bright, now it's visible imagery, and then the opposite happens at nighttime, and we're using infrared imagery colored in to make it look like clouds. But Hurricane Dorian approached the Bahamas here to get your bear. So first, the eastern islands of the Caribbean Sea. So coming across the islands, that's South America, down to the south side, to the lower side of your screen. Here comes Puerto Rico that you're seeing approaching now, and the Dominican Republic and Haiti after that, and it goes just north of Puerto Rico, starts really organizing, becomes a hurricane. You see an eye pop out briefly, became Cat 1, then Cat 2. It's now really starting to organize on this huge cloud field. It's got these great big lungs aloft, and it's approaching now the islands of the Bahamas. It's a Cat 4. And suddenly, look at that eye, now it's a Cat 5. And Dorian is approaching and approaching and approaching, and yet slowing down as it approaches. You've seen how many day-to-night cycles we've gone through. Here we go across Grand Bahama and into Long Bahama Key, and look at the island show up in the eye, and it's there for a day, and it's there for another day, and it's sitting there, and it's still just off the coast for the third day. This is Florida. If that was happening over Miami, can you imagine the devastation that would have happened? It finally got its act together, never made landfall in the U.S. until it reorganized, got really strong, started picking up steam, and caused a whole bunch of damage for the Outer Banks as it went north. Yes, it barely missed U.S. interests, kinda, but if that were 100 miles more west before it stopped, Miami would be totally changed. Forever. That is not off the table. It happened a few years ago just off our coastline. Bigger and, more importantly, slower moving hurricanes are a huge climate change signal. Maybe not the bigger, maybe not the stronger, but the slower moving we know is a climate change influence. I wanted to show you this. This is your Arctic sea ice from where it was in 1979, and then you see both the chart and the ice cube to show you the volume change of Arctic sea ice. And we're going into the 90s now, and there's ups and downs, right? Weather factors, weather changes, but the trend is really clear here as we get towards the end of this loop, that the former glory of the Arctic sea ice is never going to be the same in the current temperature environment that we have. It's just not. That is a totally different answer. And again, this one I'm going to put the sound back on and let you listen to them.
20 to 30 years ago, the sea ice covering the Arctic Ocean was dominated by ice that was many years old. This core of old ice survived all year round. Around this core, a smaller fringe of seasonal ice froze each winter and thawed each summer. Old ice eventually drifted out of the Arctic through the Fram Strait. New batches of old ice were built in the Beaufort Gyre. The gyre was a nursery where young ice grew thicker and stronger as it drifted around for many years. Today, summers in the southern branch of the Beaufort Gyre are often too warm for ice to survive. As a result, the amount of thick, old ice in the Arctic has declined significantly. In its place is young, thin ice that's likely to melt in the summer. The small amount of old, thick ice makes the Arctic vulnerable to extreme ice retreat in very warm summers. It's a situation that keeps Arctic wildlife and the people who live there poised on the edge of dramatic and possibly irreversible change.
That's the before and after. The old bright white ice compared to the new, young, brittle, totally changeable because of the weather, not even a climate story anymore, it's just a weather story ice. That has huge implications for the people there, but also here, because that's our icebox of the country, of the world. That's how the polar vortex, if you remember that trendy term from a couple years ago that's been in the scientific literature forever, but somehow made it into the popular literature a few years ago, that's how the cold air stays near the poles. When it's not as regulated and that very strong wind going around the poles slows down, then we get these wiggles and wobbles in the jet stream, and suddenly the Arctic cold plunges south, and we can get intense cold into the lower latitudes where we are. So really cold moments in an otherwise warm winter is also a climate story, and it's tied to this changing sea ice. Again, all very serious things. It's simple, it's serious, it's also very solvable. I think I saved the it's Jewish to solve it for the very end. So for now, there is indeed hope. We can all pick each other up. This is the time everyone takes a breath and goes, oh my gosh, that was horrible. Never inviting Mark back again. He's just so dark. But no, we can fix this. My favorite stat about how there's hope. The whole world uses about 165,000 terawatt hours of energy in an entire year. It's a big number. The scale doesn't really matter because in a single hour, the amount of power from the sun is 120,000 terawatt hours. If we were to somehow capture all of that, we don't even need to capture all of that. 1 hour is really close to the entire world's energy use for a year. Those scales are totally off the charts from each other, right? We don't even have to be good at capturing it. It's why solar and your efforts with solar are so important, because this is really an untapped resource. And to understand how this is an approachable area to attack, if you will, there's a great group called Drawdown. There's a Georgia version of Drawdown that really focuses in on Georgia. You should look into it. It can help guide your decisions as a shul, as a household, of where you might have endpoints to fix this. But globally, they have a study as well. And this is my favorite picture of what has been happening globally. Because he barely has shoes, he barely has clothes, and yet there's wind turbines powering this farm in the background. Lots of anti-immigrant or anti-newly industrializing nations. Oh, it's China's fault, or oh, it's India's fault. We as the U.S. don't have to do anything because China didn't come in. China is not starting with our 1965 coal-fired power plant. They're starting where they're starting still, in today's technology. It's not really comparing apples to oranges when somebody uses that argument. And so even with that, it's a little bit difficult to find how to begin, because this is such an overwhelming topic for so many people. So we're gonna narrow it down a little bit more. On this side, here's the atmosphere in the middle. So this is the air. That's our sink. That's our kitchen sink. We have the faucets going out into that sink on this side, and we have the drain coming out of the sink on the other side. If things were equal, the water level in the atmosphere wouldn't change at all. If we're taking more out, drawing down, that's how they got that name, the drawdown. If we're taking out more than we're putting in, suddenly the amount of CO2 in the air goes down, because that's our bathtub, that's our kitchen sink. There are only a few ways that we put stuff into the atmosphere. We have electricity production, there's food and agriculture, industry, transportation, buildings themselves, and a couple other small energy-related things. 5 main, maybe 6. 5, we can handle that. My 3-year-old is really good now at counting to 5 and beyond. 5, we can do that, right? It's an approachable way to think about this. 5 areas to attack. There are 2 main outs, land and ocean. I will say it's much more important to focus on the in, because there's no guarantee that the outs will be permanent. Let's say it's Tu B'Shvat, we're planting a whole bunch of trees, it's great, there are huge carbon sinks, they take that carbon, they store it up as wood, but then there's a tornado in Dunwoody, and all those trees get knocked down in a few years. That permanent tree is not as permanent as we want it to be. And so if we don't put it out there in the first place, it's much more beneficial to this story. Not to say you shouldn't plant trees, you should. But if we can also focus on how not to put these things into the air in the first place, that goes a lot further in the longest term. And within that, there are these bubbles. How effective each one of these things you can do is correlated to size of the bubble, with, if there's no new technology in the lighter color, and if there's some new technology that's forecast to occur, it's in the brighter color. So if we shift production of energy to onshore wind turbines, or to utility scale solar, or distributed like what you guys did, or at my house, because we have solar panels, huge bubbles of the energy solution start occurring. You can also enhance your efficiencies. Efficiency overall, maybe not as good as where it starts, but you also don't want to lose the energy that you're making, so efficiency is also important. Drawdown says we get to do all of these things. We don't have to just pick one. It won't work. We have to do all of them. But you, or you, or you, or me, we don't have to do all of them. We can pick. We have an in. We can do something that is possible, like putting solar on my roof, which I decided to do because of this very talk, more or less, and that was an in. That was an in to this, to that first line of the source. Food and Jews, we go hand in hand, don't we? Every event has to have a huge spread, or at least it did before COVID. Oftentimes we ordered way too much because you don't want to run out, but then we often wound up tossing that food, and it becomes methane, and it becomes a huge carbon problem. And it's not always the best, right? It's also covered in plastic one-use forks and one-use plastic plates, and lots of trash from our kiddishes and our luncheons and our Jewish history with food in both today's times and before. If we can reduce that food waste, and if we can switch more of it to a plant-based diet, we have a huge in to the food part of that source. Agriculture practices, a very trendy movie about 6 months ago or so about keeping the soils and regenerative farming and all that. Yes, very important, but regenerative annual cropping is right in here, so it's a very small bubble compared to some of the other things that can be done, but you have to do that too. All of it, as studied by Drawdown, is important. And then I'm going to start moving a little bit faster because we don't own industry, but recycling and using the landfill waste and all these things that industry can do with alternative refrigerants, globally a huge problem. Refrigerators are a really big source of carbon dioxide and other very, very powerful greenhouse gases like the chlorofluorocarbons of the past. Transportation, switching over to electric vehicles, charging those vehicles off of the first graph of charging those vehicles off of green sources, and you're really taking carbon dioxide out of the mix. Building solutions like high-performance glass, or like solar hot water heaters, and not relying on your building to have hot water because of natural gas or because of electricity. Especially if you're building new things, if you're about to do a renovation, think about how you can do that on a green scale, because now it's almost as affordable, even up front, and it's certainly more affordable if you have a longer term time horizon. This shul's not going anywhere, right? You guys are going to be here forever. You don't have to have a 2-year return of investment. You can have a 40-year return of investment on some of these things, and it starts making a lot more sense. And again, the sinks, not as helpful because things change, but we also don't want to ignore the tropics. We want to protect those forests and things like that. And in the oceans, very similar, but we don't have any influence, really, me and you. I'm not going to control what the ocean does, so I kind of left it out, because what are we going to do with that? It's not helpful for this talk. This is all of those things in a giant pie chart. And now, what was totally an unapproachable, overwhelming, so heartbreaking topic of all the bad things are going to happen, now you can pick any single thing on this list and focus on that and really start moving the needle. And I think we have, and we are going to continue to do that. As society, as the United States, I think we're getting better at becoming that global leader that we all really wanted us to be in the years past. And in the Jewish community as well, as you guys have shown from your week that you're focusing on right now. None of this is free, right? These things are really expensive. If we were to spend a giant number of $28 trillion to do all of these things, we would actually have a return of investment we would make 145 trillion globally. It's a 5-to-1 return, which you can't get anywhere else right now. Imagine putting that in my 0.2% savings account right now or something like that. It's ridiculous. But this also doesn't count the cost of climate change that we avoid. All of the wars that could start because of scarcity and all those costs, they're like, we don't know if those are going to occur. We're scientists. We can't factor those in. So they don't. And so it's a 5-to-1 return even without that. It's really good investment. And 28 trillion, while it sounds like a gigantic, unapproachable number, that's actually less than what the world subsidizes on oil and what the world spends on militaries. Not that, this doesn't have to be an either-or scenario. The point is, we can spend that kind of money if globally we wanted to. If there was a push to do that very thing, it can happen. So finally, I want to talk briefly, because I want to leave time for questions, about 5 minutes until I start talking, and then as many questions as you want. It's shalom, and I love this analogy that I found for the word shalom, meaning peace. Without peace, means other things in Hebrew, I know, but without working on this climate solution, we can't have the peace that we would be hoping for. The shin in shalom, often representative of fire. We know the history or the current day of the increased fire threat. What just happened in Colorado could not have happened without climate influence of a long drying out, a burst of new growth, and then an insane wind to then burn that newly dried material. The wind probably would have been there in the past, but that exact order would not have happened in that way to that magnitude without our influence. The Lamed, it is the tallest letter, right? The tall order that this is. It is there's more to this one that I can't remember at the moment, but we know that this is a big deal, and it is intrinsically Jewish to do this tall order that is part of this. The Vav in Shalom, also representative of the number 6, the 6 days to create the world before the rest. So 6 was a very important global pattern within the word shalom. And then the mem, often representative of water or mayim, and the water influences that climate change has. So I use this as a framework to kind of ground myself within why this work is both environmental and my work self for the weather, where I work at the Weather Channel, but also my Jewish self and my non-work self. These intersect, and that is my grounding for some of that. Otherwise, within Judaism, some of this was talked about in the intro from your rabbi, which was awesome. It might be repetitive. I put up the picture of Adam and Eve naming the animals, right? You don't care about things until there's a name. This is part of why that story is part of our culture and why there are names given to hurricanes, because we know through social science that nobody pays attention until there's a name attached to it, even if it's just as deadly. Deadly heat wave that kills way more people doesn't get any press, but Tropical Storm Mark absolutely will. The name matters. Naming the animals mattered. We're supposed to care for those animals, and we are having extinction rates at off the charts levels that we haven't experienced other than known extinction events like asteroids, giant volcanoes. This is much more in our control than giant volcano. We can do this. The Noah story, the floods, the promise that we wouldn't flood again, and yet you look at places like Ellicott City in Maryland that had unbelievable floods twice. The 100-year flood, which now means absolutely nothing because the climate has changed so fast that our averages haven't been able to keep up with them. This is the Noah story again, and we know that story well. It's Tu B'Shvat. We are so fortunate to be a religion that has a holiday for the trees. I mean, if that doesn't speak to Jews tackling this issue, I don't know what will. And then I put up the kind of the buzzwords of Jewish life, and one of the top ones is morals and justice and people. More and more, climate change is not an environmental story, but a justice story. Because we know that the impacts from a changing world will impact the poorest people and the poorest nations first, but also the poorest people in the rich nations, off the charts more than the richer people in those same countries. This is a moral problem. Judaism and morals, now that's something that we understand, we can talk to. Science and religion, questionable love-hate relationship there over history. Religion and morals, now we're talking. We know how to do what's just and what's right and wrong. Our tradition teaches us this perfectly, and climate change is that. It is the need for that justice story. And of course, we mentioned Tikkun Olam. It is every Jewish kid gets taught, this is who we are, this is why we are, this is what we do. We're supposed to repair the world. This is something that needs repairing right now. And it is the Shemitah year, so I would be remiss without pulling up that Shemitah is happening. And through JCAN, the Jewish Climate Action Network, if you're not involved yet, talk to Robert. He will get you involved. But it's an amazing group of people that have come together, mostly online at this point, but have done some amazing work already within the Atlanta and the Georgia Jewish communities. They put this out where, all of these things can happen as part of your Shemitah plan. If you're working on a Shemitah plan in your shul, you can look at reducing your carbon footprint through GIPL, through energy audits, through matching grants. You can look at teaching opportunities and learning opportunities. Other big groups that do this, Hazon, Aras, the schools in the area, the Jewish day schools, Limud, establishing that connection between sustainability, between Torah, and between Jewish values. Advocacy. Some of these big things are not approachable by one house putting up solar. It may need the fact that, it might need Georgia law saying, no, the solar that you put on your roof has to be bought back by Georgia Power at the rate that you buy it from. Because while my system actually qualifies for that, a system going up today gets something along the lines of between 3 or 13 cents per dollar. It's my opinion, and people can be mad at me for saying it, it's robbery by Georgia Power to take something off that you produce and then charge it back to you at 70 cents more than what they paid per dollar. It's crazy, but that requires a change in law. So advocacy is a huge part of this. We can mobilize the Jewish support for critical federal and state climate policies. Jewish Earth Alliance does this. Dayenu does this. Green teams. You have a green team here. And those green teams are planting trees, like you guys talked about for Monday. Compost, as I talked about with the food and food waste, a huge in for a green team of a synagogue because of the connection between Jews and food. And understanding those connections between Jewish tradition and outdoors with your beautiful new outdoor prayer space. All right, you guys are doing this. This number 4 is like, you guys are the shul, right? There should be a sign up with your name on it for number 4. And the youth movement is super important too. Jump Spark in the Atlanta area is a great way of looking at the youth movement. All to say that even within this 1 year, or if you want to look at it on a longer time scale, the Shemitah cycle before the next Shemitah year, so 7 years from now or so, you have the opportunity to think about this in a slightly different way and do a strategic plan for the earth from your shul. And I think more and more Jewish communities are starting to look at this in that way and say, this is where we belong, this is who we are, and we are going to be the face that helps to fix this, the faces of the change. And the Jewish community is really starting to step up. And again, I thank you guys for bringing me in and helping to encourage that within this Jewish community, because I think you have an awesome opportunity to continue to do so.
Thank you, Mark, very much. This is not the first time I've heard this presentation, but every time I hear it, I enjoy it and I learn something.
Well,
so
thank you.
I appreciate that very much. For the online people, they will not be able to hear your questions. So I will ask you to ask short questions so that Mark can repeat them.
Yeah.
And then Mark will answer them once you've asked. So with that, does anybody have a question? B.
Yeah. Yeah.
What can we do to bigger move that needle? Because it doesn't.
Yeah, I hear what you're saying. So the question is, for people that are watching online, it feels totally overwhelming as an individual to try to tackle any of this when it requires a global attack or a global way of solving. Global climate change can't be solved by one person's house. And that is absolutely true. And so the question being, how do you begin? Where do you go? Those advocacy groups that I had on that slide are a great way to go because it makes your one small voice so much bigger. The Jewish community comes together in those, and suddenly you have lobbyists that know how to do it and are talking to those lawmakers, and the backing of all of those people. I got involved with Emanu-El over the beginning of the pandemic. They brought me in on one of their cold call nights to inspire people to that were doing those calls, because again, your one action is really it does feel totally unapproachable and unstartable, but combined, all the Jews in the world acting together, suddenly you have a force, right? I mean, so it's about finding your group. But even without that, the slides I showed you about with all the bubbles and the things that you can approach, it's both. We need the individual homes to tackle their individual homes efficiency and their individual homes energy use, meaning are they using solar, are they using a solar hot water heater? I have a driveway that's got a few more cracks in it than I would like right now, and there are ways that I can look at that and do traditional concrete, or I can find companies in Atlanta that use green concrete and capture the emissions that come through that process, which is actually huge. Or there are some totally alternative driveways that use a lattice type move, and there's grass that grows in that lattice, and it's still just as stable of a driveway. My wife didn't love that idea. She doesn't really want me mowing the driveway on top of mowing the lawn, but we'll see. There's ways that the households can really change their carbon footprint. And the drawdown group says it's not just that you should, it's that we have to at each individual building level and family level start changing. And so you shouldn't feel overwhelmed in that way. You should feel empowered that you are adding to that, that you're even considering solar is so much further along than so many other people. And while your energy company should be doing better to encourage this, of all those other externalities that come from solar and from helping everyone else, they're going to focus on their bottom line, and so it's not as easy a sell to them. But there are batteries that then capture what you store and you use it. It's expensive. It becomes much more 10 years. That's crazy.
So, Mark, I know your shul is Al-Havathachim, the AA,
yeah.
and you guys are working on putting solar on your building.
We are.
Can you tell us a little about that project and how you got to where you are?
It's been a process. So I put solar at my house, and after doing that said, okay, that wasn't quite as bad as I thought it would be, although it wasn't easy necessarily, right? You have contractors, you have different groups, you have different companies, and so I approached the leadership of my synagogue and I said, what would it take for us to get solar? And luckily, the executive director, Barry, said, this is the right thing to do. You don't have to convince me that it's the right thing to do. We should explore this. And so I got the green light almost immediately, which was empowering, right? It was very helpful to that process. And then I said, okay, here's what I'm going to do. I'm going to do all the hard work, and you're just going to be invited to the meetings. And I said, I'm going to look at all of the solar companies that I can find, and I'm going to do an analysis of them, and I'm going to bring you one or two that I think have the right combination of cheaper product, potentially, and most importantly, longevity in the state. Because I didn't want them to disappear partway through the project, and I didn't want them to be gone if they warranted your panels. If they don't exist in 20 years, that's a problem as well. And then through Gipple, we found that we're not the first, prayer place to look at doing solar. They have that experience already. So we looped in Gipple. We found the relationships that Gipple already had, which brought us to two main providers that were already on my short list, which was Creative Solar and Cherry Street. Those two not only have a long history in the state, but are also the only two so far that are doing solar energy procurement agreements where they are turning into the energy provider. So if they already have all of these solar panels across the state and they're getting money from them, they're not going to pick up and leave. That's their job. If they leave, they don't get the money anymore, just the business does. And so we're now working with those two groups who have slightly different views on how they put up solar, how many panels they put up, how conservative their estimates are for their rate increases versus Georgia Power's rate increases, because the difference over time is really how you make your money back. And they are going to own the solar panels. They are going to install them for almost no upfront cost to us, and we will then buy that energy back from them and buy our normal Georgia Power leftover energy. So we're going to have two power bills, one that is solar, one that's traditional, and that the solar will more than offset the cost savings from Georgia Power, but it's a higher rate than if we were to buy it ourselves, and that difference is how those companies make money. So everyone's taking a slice, and that's how we've approached it at AA, and we're almost there. We're almost to the point that we can say we're moving forward, and it's going to happen.
Yeah, so you're an expert in the field, so I just kind of want to get your opinion on something.
Sure.
So, you know all about major hurricanes that have taken place over the years and devastation that is created. You see constantly advertising on TV about these poor total leaders that don't have place to hang out, blah, 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 so forth and so on. So, what, from a priority standpoint, in your opinion, could, let's say, the United States do is not going to control anything else? I mean, especially you can't do it. In other words, if we went totally
Yeah.
which of these would create the best environmental benefit to help the carbon dioxide problem reduce? So,
Sure. So the question is for anyone that's watching, what can, as the United States, if you had to pick one direction to move in to tackle climate issues, what would be the one thing that the United States on the whole should do to best help the carbon footprint of the country? Did I summarize that well? Okay. It's a tough answer because, again, that drawdown graphic says we can't just do one thing. We have to do all those things. And again, I know what you're saying, because we can't control what other countries do, and we can't depend on them to do it, so what should we do? Alternative energy and green energy is really an easy move overall if the United States wanted to move in that direction, with a bunch of caveats. It's very different than traditional energy. It probably requires a different power grid to move that energy across the country. We've seen what happens when power companies don't share their power grid and run out of power, like what happened in Texas when they were not connected to everyone else. They had an intense winter storm, really cold. They had to basically shut down everything because if they didn't, power would flow back the wrong way and everything would have caught fire and burned down. So, switching over to entirely, and I use the air quotes, solar and wind and on a country scale is possible, but it requires more things. Getting rid of coal and the transport of that coal would be a huge notch in the positive column of the direction we want to go in. And so the longer answer than I think you wanted, I think energy production is one of the ways that this country can tackle climate change the fastest, but it doesn't come at zero cost, and it doesn't come at zero infrastructure dollars to do even outside of the new plants that would be needed, like the lines and the connectivity and all of that would have to come with it. Very possible to do.
All right, one last one, and then we'll wrap up. Go ahead, Phil.
so there's a sense of urgency here.
Yeah.
I mean, we don't have an unbelievable amount of extra time. So what is the clock as you're looking at it before it gets to that 2.0?
Yeah, the clock, so the question is, there's a sense of urgency here and you have to move faster. I think that's the kind of the point of the Glasgow summit, and what came out of that was that we were not moving fast enough, that even if every country held on to their commitments from the Paris Agreement, some of which are already behind schedule, that they wouldn't limit the amount of warming to stop some of the most catastrophic impacts globally. Glasgow's talks tried to fix that, and globally they are re-meeting at a much faster pace than ever before. There's another summit next year with some of the biggest countries, and then they bring back some of the smaller countries. It's happening. That acceleration is beginning. Again, it shouldn't be, well, it's hopeless. We can't fulfill these goals. As you mentioned, as the expert in the room, I don't think that that's the case. I think we can meet these goals and we can stop that warming. It does take some effort, and I think we're getting there globally, and we're certainly getting there on the city scale, when the mayors of all the major cities have pledged much more than the Paris Agreement, and they are ahead of pace. New York City, San Francisco, Atlanta, they are all ahead of their pledges for switching over to greener solutions.
So I want to thank you, Mark, very much for coming. It's been a great presentation. Thank you. For those watching and those in the room, this is part of a series that we call TE Talks. Harriet Zoller is the chair of that group, and we do these things on about an every other month basis throughout the year. So I would encourage you, when you see stuff come through on Kesher Quick about other TE topics, please take the time. They are all carefully thought out, and in this case, certainly very well presented. So I thank you very, very much for being here.
Thank you.